So scalar multiplication of matrices is pretty simple. Multiplying a matrix by a scalar um, is pretty straightforward. It's not like multiplying a matrix by another matrix. That's kind of a doozy chore. But multiplying by scalar, that's pretty nice. A scalar is like the number 2 or 8. Um, some simple number that if you multiply something else by it, it's scaled up or scaled down. 1/2. It's a scalar. So it's all you do is you just multiply each of the elements of the matrix by the scalar. So for example, um, if I want to multiply this matrix A by the scalar 2, I multiply each element by 2. So 2A would equal, so 1 times 2 is 2, 2 times 2 is 4, 3 times 2 is 6, 2 times 2 is 4, 5 times 5 times 2 is 10, 9 times 2 is 18. Boom, done. Right? So you just multiply each element by the scalar. Oh, wait, this is weird. Let's set A. I don't know why. So we could multiply this matrix B by the scalar -3. So we multiply each element. So it's got 3 rows, 3 columns. So it's a little different from A, but doesn't matter. You just multiply each element. So the new matrix is going to have the same dimensions as the old matrix. You just multiply each element by the scalar. So 0 times -3 is 0. 10 times -3 is -30. 11 times -3 is -33. -2 times -3 is 6. 4 times -3 is -12. 7 times -3 is -21. 7 times -3 is also -21. 2 times -3 is -6. 1 times -3 is -3. So that's all it is. Scalar multiplication. It is useful when you're solving systems of equations with matrices. You may need to scale an entire row up by a scalar or down or whatever. It's equivalent to, if you take, just a little side note here, because I can. Let's say you have some linear equation like that. When you're solving a system of equations, maybe you want to solve by adding the equations together. Well, if you make this into a -6, -6 plus +6, the x's will be gone. So you'd multiply this whole equation by a scalar, by -2. So this would be -6x plus -4y equals -20, and then you add them. So that's kind of what's going on here. All right, have fun. See you later.